So in this video, I'm going to do some practice problems for Lewis dot structures, drawing them, and determining the formal charge. So let's do some examples. In the last video, I explained how to determine what the formal charge was and how to draw a little bit of Lewis structures. So let's try one. BeF2. And so what this is going to look like is it's going to be BeF2. And that's because fluorine, ideally for a neutral fluorine, likes to have this type of configuration. And beryllium likes to have two bonds coming off of it. And so let's try and determine the formal charge. And so the neutral charge for beryllium, we'll do that first, is it has 2 valence electrons minus 0 lone pair electrons minus 1/2 of 4, because you have 2 electrons in each of those bonds, and that's the formula. And then so that gives you a formal charge of 0. So beryllium in this is neutral. Now let's try fluorine. So fluorine has 7 valence electrons minus 6 bond lone pair electrons, so 6 dots, and then minus 1/2 of 2, which is the number of bonds that it has, and then that gives you again a formal charge of 0. Now let's try a different one. So let's try Br5. And so Br generally likes to have this type of formation for it to be neutral. And P, this one is a little tricky. So this is what it actually looks like. Br, Br, Br. And so one thing you might be thinking is that, wait, P is violating the octet rule, phosphorus is violating the octet rule, but since it's in the third group, the third row, it can actually hold more than 8 electrons in its valence shell. So as you know right now from the past example we gave, bromine would be formal charge 0, neutral. Now, let's do phosphorus. So phosphorus has 5 valence electrons minus 0 lone pair electrons, and then minus 1/2 of how many electrons? So it has 10 bonds, 5 bonds, which is 10 electrons, and that gives you a formal charge of 0. And so let's do one more. One more, it's an exception. So it's a special case, SF5 minus. And so you have S, F, 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 and so all of the F's are neutral. And so from the previous example, we determined that F, the fluorine, has a 0 formal charge. Now let's do sulfur. So sulfur has 6 valence electrons minus 2 lone pair electrons, and then minus 1/2 of 10, because you have 10 electrons with the bonding, and then so that actually gives you a -1 formal charge. And notice how this corresponds to that charge. That's a good way of determining what the formal charges have to add up to be. So the whole molecule, the formal charge added up will be equal to the total charge on the whole molecule. And so here we would write that the sulfur has a negative charge on it, a -1 charge.